This is the 2011 Relative Velocity Q2b. A woman can row a boat at 4 meters per second in still water. She rows across a river 80 meters wide, and we have the flow of the river at 3.5 meters a second. We'll take the river going this way, and she wishes to land between B and C here, B being the shortest distance. The point B directly across, we're told here, directly across the shortest distance, and C is 20√3 downstream from B. This distance is 20√3. So if theta is the direction she takes, find the range of values. So she's going off in this direction, and we can see theta here on the x-axis. So when we start here, we can start with the shortest distance, B, A, and we have her, the woman, we have her rowing at 4 meters per second in this direction, the river flowing in this direction, so she'll end up with B, the river at 3.5, and the woman at 4. So we can get this angle in here with the velocities. We have opposite and hypotenuse, so we're going to use sine of theta is equal to 3.5 over 4. So the inverse sine of 3.5 over 4 is equal to 61.04 degrees. Probably should have called the angle something other than theta, because we're actually looking for the angle in here. So I'll just change the name of it. I can rub it out. Call this one A, and I'll call this one theta in here. So theta is equal to 90 minus 61.04, which is going to be 30, 29, 28.96. So that's to get to B. So let's do a diagram then for C. So we're at A, we're going to go in this direction, and we're going to land down at C. So here's my A, my C, and I have the woman's gonna, we'll call this one, well, we don't need the point here because we're never going to reach this point here, we'll call it D, it doesn't really matter. This is 4 meters per second and the river is 3.5. You can see we don't have any angles in the triangle, so this is where we're going to use the 20√3. This should help us get this angle over here. We'll call it the angle C because it's at the point C. So we have 20√3, and we have the width of the river, so we're using the distance this time to help us. We were using the velocity in the first part. So we can say we have opposite and adjacent, so we're going to say the inverse tan of opposite over adjacent, 80 over 20√3 will give us C. So C is equal to 66.59 degrees. So we can put that in here, 66.59. This to get this angle here using the sine rule. So we call this angle in here, and we call it the angle E. Doesn't really matter. So the sine of 66.59 over 4 is equal to the sine of E over 3.5. So 3.5 sine 66.59 is equal to 4 sine E. So don't write the 4 down, we're going to divide by it. So the inverse sine of this, we can just write down E. You type into your calculator the inverse sine of the left hand side will give me, well, it gives me, if you want to write sine E equals 0.803, do it in stages, slightly rounding it off, we're going to get B or E to be 53.41 degrees. That angle. Now the angle we're looking for is this angle in here. I'll call this theta 1, I'll call this one theta 2. So we have E, so This angle here is alternate to theta 2. This is also theta 2. So 180 take away 66.59. 180 take away 66.59. Take away E, 53.41. 59 and 41 is 100, and that's 120. That equals an even 60 degrees. So that's going to be theta 2. So the launch angle for theta to get between C and D needs to be between the first angle we got, 28.96, and 60 degrees.